Greetings of the day. I'm S.K. Manocha and I'm here for the discussion of geography questions which appeared in paper 1 of the main examination yesterday. The first question is, what is sea surface temperature rise and how does it affect the formation of tropical cyclones? Now, in particular, before I start for the details, let me mark two observations here. The first is that each year examination is again reminding all of us, the students as well as the teachers, that the core part of the strategy for success in this examination is the reading of the newspaper. That even in static areas of geography, you have the questions which are being guided from the current affairs. And all four questions to me are a reflection of the same. And the second observation I wish to make here is that the simplest rule you need to follow for good answer writing is that always attempt writing what is being asked in the question. So with this, when we look at the first part of the question, it says, what is sea surface temperature rise? The first is that you relate this sea surface temperature increase or rise to climate change. And then you can relate it to the kind of complex phenomena we have heard of through newspaper, that El Nino, La Nina, and Indian Ocean dipole, Madden-Julian oscillations, and a few other such same oscillations in other parts of the world. So primarily we give importance to the climate change here first for the sea surface temperature. So give a sentence definition of climate change, that it is a change in the average temperature of the earth's surface. And this is all because of the heat budget getting disturbed. And today when we are on the earth, this heat budget is getting disturbed for both the sets of reasons, natural and anthropogenic. And having mentioned that, then you can give a factual information that what has been the estimation of the scientific community for this change of temperature or the rise in temperature because of global warming in the present times. And since it is sea surface temperature question, so there is a scientific evidence through various studies that since 1850, we have an increase of temperature of the sea surface by about 0.89 degrees centigrade. It is less than what we had on the land as such. And now, having mentioned this rise of temperature, we would talk about the nature of the tropical cyclones, which is there in the second part, that we have to relate it to the formation of tropical cyclones. Now, you would have read that tropical cyclones are thermal in origin. By this we mean they need enormous amounts of energy for their formation and persistence in nature for 6-7 days on an average. And this energy they get through latent heat, and the latent heat comes from the vapor, and vapor, most of the vapor, if not all, to the atmospheric circulations comes from the ocean. So since our cyclones are thermal in origin, when I say our cyclones, it means tropical cyclones, they are only formed over the oceans because they need that enormous energy through vapor in the form of latent heat. And when they reach the land, they happen to die. One, because their energy source gets cut off, and second, friction of the land would also affect negatively these tropical cyclones. So it means if we have the thermal origin of the cyclones, so logically it appears immediately on the face that they certainly would have some influence from the rise of temperature on the sea surface because of climate change or because of the kind of the regular kind of changes we get in the form of Indian Ocean dipole between eastern part of Indian Ocean and western part of Indian Ocean. And similarly, when we talk about the change of temperature on the surface of Eastern Pacific and Western Pacific, when we talk about El Nino and La Nina kind of oscillations. So whenever there is a change of the surface temperature, certainly there would be a change in the frequency and the intensity of these cyclones. So, having mentioned this, now we particularly write about two preconditions along with, the number of other conditions, but besides the other conditions which are not relevant for this question, the two main conditions relating to sea surface temperature would be that cyclones in tropical areas need a warm surface, and scientific studies have shown that a low pressure system called ITCZ would have chances to become a tropical cyclone, an intense low pressure system, when the sea surface temperature is 27 degrees centigrade or more. And since it needs a lot of energy in the form of latent heat, so the times when you have very warm and moist air over the ocean surface, perhaps they would be the best times for the origin of a tropical cyclone. So these are the two favorable conditions out of 5 or 6 which we list otherwise in general, but these are the ones which relate to the topic, the question asked. And then we can give the factual information that scientifically we have seen in the last 4 or 5 decades, there is an increase in the frequency and intensity also has got enhanced of the cyclones in Atlantic Ocean or in the South Indian Ocean or the parts of the Pacific Ocean. So it means there's a direct link between SST, the sea surface temperature, and the both frequency and intensity of these tropical cyclones. And then later you can talk about El Nino, La Nina and Indian Ocean dipole. Since it is for, you have limited words to write, 150 words only. So I would suggest that you can go for one oscillation, the El Nino as such, that even those changes which are there related to ENSO, El Nino and Southern Oscillation in the Pacific Ocean, that would have its bearing on both the frequency and intensity of these cyclones in certain parts of the world. And for the future, we should end this answer by writing that one of the difficult areas for the scientific community in climate change models is to predict about the cyclones in the tropical areas. Because these tropical cyclones on one hand are very essential for energy transfer from one area of the world to another, and second, they give us plenty of rain in one go in the coastal regions, but at the same time they are so destructive systems, so we need to have the predictability for these cyclones through our scientific models and all that. But this is going to be a tough task for the scholars in the future, because what is happening is that the climate change models are suggesting uncertain picture about global warming, the future we have for the earth, and more so the kind of oscillations like ENSO and others, they are also having a lot of increasing variability, and it would become further difficult because of climate change complexities and the related aspects of El Nino, Indian Ocean dipole, Madden-Julian oscillations, that what kind of final picture we can have for the tropical cyclones. So at the end I write here that increasing ENSO variability with global warming will also influence the number and intensity of tropical storms in unpredictable ways. So it means there are 3 parts of the answer basically. That first you talk about climate change, the sea surface temperature, then talk about the origin, the nature of these tropical cyclones, and then make a connection, and then at the end give a sort of future idea that what exactly is the task ahead for the scientific community of the world. Now we come to second question. The second question is about what is the phenomenon of cloudburst, always in news. So again, my point is substantiated that even in static areas of geography, you have all the reasons to make the newspaper reading. Means basically you need to focus on what the world is talking about in the last 1.5 years, what India as a nation is talking about itself. That would give you the questions for the examination, not only in the current, but even in the static areas of your examination syllabus. Now, in this question, when he says, what is the phenomenon of cloudburst? And he says, explain it. So basically, you have to tell in the simplest ways possible that what exactly is this phenomenon and the related dimensions of it. Now see, first of all, you must tell the examiner that in reality, in real sense, there is no bursting of clouds ever. Physically, clouds do not have any bursting. But the term is popular only for the reason that it has gone from the mouths of the people to the books of science. It's not a scientifically given term. It is a fanciful term. It means basically cloud burst is too much of rain in too short a time, making the people of an area comment, it appears as if cloud has busted today. So it is too much of rain in too short a time. And that's what you see in the first sentence there, that it's a very sudden concentrated downpour of water. And then go for a little of technicality of this particular point, that it generally affects a small area. Because for too much of rain, you need a big cloud. And the clouds which are the principal clouds for the cloud bursts, they are the vertically developed clouds. And the best is the example called cumulonimbus cloud. These clouds start from very close to the Earth's surface, and they are vertically extended for 13, 14, 15, 16 kilometers, almost covering the whole troposphere. And this big cloud has so much capacity that it can give you rain in one area in just one day, what that area otherwise may not get in 1 year's time. So you need a lot of convection for this kind of cloud to form, and you need intense kind of a heating of an area. And for intense heating, you have the sun's rays vertically or close to vertical, means the rays have to be at higher angles. And when the sun's rays come at higher angles, then the area which is being heated would be less for intense process. If the rays come inclined, then the heating would be more diffused, and those kind of cases will not give us these vertically developed clouds as such. So basically, it is caused by intense localized convection rising of air. It means it affects generally a small area, and there's a very concentrated kind of downpour of water. And if we go by technical ways, like if we go by the definition given by Indian Meteorological Department, then cloudburst is a particular situation where you have more than 10 centimeters rain per hour in more than or equal to 10 centimeters of rain in 1 hour in a small area, and generally that area is taken as 10 by 10 square kilometers area. And since the area affected is small and you cannot predict the amount of rainfall in exact ways, so prediction about such an event is not that easy. We can predict easily for large areas and more for the heavy or medium or less rainfall, etc. But to have exact quantification of rain in terms of amount, and that too for a small area, you need a dense network of all such weather instruments, and you need a great analysis, which perhaps is not possible for every part of the country. And this particular cloudburst is related to thunderstorm situation, that you have vertically developed clouds which have charged particles there, and there's a sort of flash that you have thunder, etc. Again, all the evidence of great convection. And the cumulonimbus clouds, which are the principal thunderstorm clouds, they would never be seen in polar areas. It means they would be seen in more often the tropical region, because tropical areas are where you have both the things together in abundance, that you have intense heat as well as great moisture with the air, because warm air can hold more of moisture. So you may have such clouds in the middle latitudes also, for example, related to a cold front. But more of this convectional process which is needed for a cloudburst is seen in the tropical areas. Now, generally we will see that cloudbursts which are there in mountainous regions or in the urban areas, the big cities, they leave lasting impressions in our mind, and they leave like deeper impressions. And generally we tend to believe that cloudburst is more a feature related to the mountainous region. No. The point is, technically speaking, cloudburst can happen in any area. But when this cloudburst happens in a mountainous region, then the features of that area would be the reasons for the intensification of convection. It means cloud formation of that extent, what we need for this particular cloudburst would be more easily available. For example, area of the steep slopes would not only increase the area for the sun to heat, but also the time for the sun to heat a region. And then when too much of rain happens out of a cumulonimbus cloud, then imagine, then you have all the possibilities of the glacial lake outflows in mountains like Himalayas, which would give us too much of water being released along with the water of a cumulonimbus cloud, then you may have a lot of loose material on the slopes of the mountains which are under a delicate balance, and they may get disturbed, and you may have mass movements of huge scale taking place along with that cloudburst. So it means basically we are saying when this tragedy happens or this cloudburst happens in a mountainous region, then you will have the aerial extent of it as well as the intensity of it. Means the whole impact will get widespread, and the intensity and the impact will be many a fold than what it would have been in a plain area. In similar way, in the urban centers, we have created such conditions today. For example, we have the too much of built up area. So that built up area of the buildings and other such things would also be aiding in the process of convection by increasing the area for the sun to heat as well as the time for the sun to heat. And then you will have the change of albedos in urban centers of the surfaces, that many surfaces are darker surface. For example, the black material on the road would absorb a lot, reflect very less. The albedo of that black material on the roads we see in the urban centers, the bituminous material, has only an albedo of 10%, 90% heat gets absorbed. So all surfaces changes which we have done, they have led to changes in albedos. Then we have many such kind of things which are emitting heat in urban centers, the cars we use, the vehicles in general, and the machines in the industries. And then furthermore, what we have done is we have eaten away the wetlands of an urban center, like Chennai for example. It means the water which could have been absorbed during a heavy rain, that is not being done. It means the runoff in these areas is much more than what it would have been if it was a natural surface area. We have blocked the drainage channels in urban centers. So all these kind of things, they have coupled together to make this cloudburst much more intense in terms of the impact in an urban center. So in the mountainous region, the aerial spread is too much, intensity gets many a fold, and in urban centers, the tragedy becomes many a fold in terms of intensity, and all these kind of reasons become the reasons for more of lasting impressions of these episodes in our mind. And that is why we tend to think of these areas first whenever there is a cloudburst. And now, what kind of suggestions we have to give here? Towards the end means having written number of details, I can't go into all of the points today because we have to make it a brief kind of discussion. So in the last, you can relate it to the kind of things we can make a suggestion for. First, you need to give some examples of such infamous episodes where we had a lot of loss of lives, loss of property infrastructure, plus you had the kind of soil erosion in an area. Remember when there is a huge flood associated with a cloudburst, then it does a lot of damage in terms of soil erosion in that region. Means light rains over months will not do the damage what one rain can do in a cloudburst as such. And then we have to have some lesson for disaster management. For example, we Indians need to have a complete record of the glacial lakes we have in the Himalayas or other such kind of features of topography which can give us the idea that how much water would flow in an area if there is a cloudburst of any kind as such. But unfortunately to say that we Indians perhaps have no learning from history. There's a saying that we learn from history, that we do not learn from history. I believe this particular statement is true to a large extent in India's context, that there have been many episodes of cloudburst in urban areas as well as in the Himalayan region, and we have been having such great losses, but still a lot is to go in terms of disaster management in the true sense as such. We do talk about it, we are taking some steps, but perhaps India needs to go for a revamping of those steps, and it has to be done on a war footing because these kind of disasters are getting more and more anthropogenic in nature, though they might be listed as natural disasters on the face of it, but the human factors in urban areas and mountainous region are perhaps adding much more in the intensity of this tragedy as such, or the cloudburst. Now, having said this all, now we come to the next question. The next question is about the spectacular lights we have in our higher latitudes of the northern hemisphere and southern hemisphere. The question says, what are aurora australis and aurora borealis? And then the second part of the question says, how are these events or how are these triggered? and we have to write this answer in 250 words. It means you need to give some particular details of how these lights we see in the sky in higher latitudes of both the hemisphere. Now see, to just to mention to begin with, that I would say these auroras which are there in the northern hemisphere and southern hemisphere, these are like light shows of Mother Nature. That Mother Nature goes for spectacular, fascinating kind of shades of lights like the green, red and violet in higher altitudes in terms of say more than 80 kilometers, means it is in the zone called thermosphere of the atmosphere beyond mesosphere. And secondly, it is in general in the higher latitudes of both the hemisphere. Now basically the story is about this event is about the interaction of the charged particles which are coming from the sun at great speeds towards the earth. And these charged particles, when they enter the magnetic field of the earth, then these charged particles are taken towards the poles through the magnetic lines of force. And there these charged particles of the sun, which are in solar wind, they are basically interacting with the atoms of the gases like oxygen and nitrogen. And these interactions of the high energy particles would make the atoms of gases like oxygen and nitrogen, they will get excited to the higher energy levels, means the electrons of these would get excited to higher energy levels. And when they de-excite, they emit certain radiations in the visible range, and those are what we see as the colors. And depending on the gas which we are talking about, if it is oxygen, you may have the green and red kind of shades, and if you have nitrogen, then you have red and violet kind of shades. And when they go for the fades, like there is a phase when the light may fades and then may strengthen, and then you have such kind of variations, giving a beautiful sky when this event happens. Now, let us make it in a little structured way. In this question, when you are talking about the phenomenon in the first part, then you first talk about solar wind. You know there is ionized gas in the sun, and from the outer surface of the sun, these ionized gases get some velocity and they escape from the gravity of the sun, and then they travel at great speeds, and some of them would come towards the earth. But earth has a protective shield in the form of a magnetic field. So that zone which is being covered around the earth by the magnetic field is called magnetosphere. Now let me show you this diagram here, this sketch. The side of the earth which is facing the sun, the solar wind which is coming, that would suppress the lines, the magnetic lines of force of this earth's magnetism. You know, earth's magnetism is like a bar magnet, means as if a bar magnet is there inside the earth. But in reality, you know, there are convection currents in the core of the earth, and through those convection currents we are getting the magnetism being produced every moment of the time as such. But the behavior is almost similar to the behavior of a bar magnet. So there are two ends, the north pole and the south pole of this magnet. And what happens is the solar wind would suppress the magnetosphere on one side, and the other side would get elongated. So magnetosphere, that shield which is there around the earth, is an extended kind of a shield on one side which is away from the sun. It means it takes the shape of a teardrop, and on the side which is facing the sun, it is compressed by the high energy particles of the solar wind. Now, so first you have to talk about solar wind, and then you have to mention what the colorful lights we have, the interactions we have of the solar wind high energy particles with the atoms of the gases in the ionosphere, the thermosphere of the atmosphere. And there is a linkage we have to establish because it's a long question you have to answer, and you have to write 1500 words on it. So then you talk about the intensity of this solar wind in relation to what is called the sunspot activity. You know, there's a cycle of about 11 years of the sunspot, and you know there are active phases of the sun, and when you have active phases, the sun has more of sunspots on the outer surface. Sunspots are those areas which are the dark areas where the temperature is less by 1500 to 2000 degrees centigrade as compared to the surrounding areas. But the rule is when sun has active period, that is when you have more sunspots on the surface, the outer surface of the sun, that is the time then you have stronger kind of flares from the sun. It means you are being bombarded with more of energy particles at great speeds, and when these particles reach the earth, some of them would penetrate into the earth's magnetic field. And when they penetrate inside, when it is very strong and more energy particles, they may reach much interior into the magnetic field of the earth. And when they reach more interior in the magnetosphere, that is the time when these charged particles may show these spectacular kind of lights even in the lower latitudes than the polar region as such. It means sometimes these lights are seen as far as south in the northern hemisphere, say southern US. But most of the time when the sun is not in its active period, we see this particular colorful kind of shows only in the polar region, the higher latitudes of both the hemispheres. So basically the point is that solar wind particles, which are high energy particles emitted by the sun, they are interacting with the atoms and the molecules of the gases like oxygen and nitrogen, which are in the upper atmosphere, means at a height more than 80 kilometers. So we have more of the colors being seen in the areas near the North Pole and South Pole, where you have the magnetic poles of the earth. And here I have mentioned, during the periods of high solar activity, the solar wind is more dense, it travels much faster and carries more energy. When these energized solar particles reach earth, they cause a variety of effects, such as changing the shape of the magnetosphere. As I've shown you, this side it is elongated, but whereas on the side facing the sun it is compressed, it's compressed to a smaller size as such. And these high energy particles excite the atoms and molecules in the upper atmosphere. The excited atmospheric gases emit visible radiation, which causes the sky to glow like a neon light. So basically, the atoms of gases like oxygen and nitrogen, they get excited. So electrons move to the high energy level. And when this excitement is over, in the de-excitement period, they release that extra energy which was given by the high energy particles. And during those, there are emissions in the visible light range, and that is the light we see here. So as I told you earlier, that atomic oxygen can emit green or red light, and molecular nitrogen gives off red and violet. The shades of these colors can be spectacular as they brighten and fade. The auroras, as I told you, they are more seen in the polar latitudes because, you know, our Earth's magnetism is like the magnetism of a bar magnet. So the lines of force, magnetic force, are converging finally at the North Pole and South Pole, the magnetic North and South Pole. So these high charge particles are driven towards those locations only, and there we see these particles interacting with the things or the atoms and molecules of the gases in the upper atmosphere, in thermosphere, which is generally more than 80 kilometers in height. So it means higher latitudes and higher elevations of the atmosphere, we see these lights in general, but sometimes they may come to little lower latitudes also. And these kind of things have been in news. Perhaps that is the reason that you got this question in the examination. And this is related to your sunspot cycle also. So you can make at the end that connection, and that would be a good answer to the question. So here I have written about that cycle of 11 years. And I write here, sometimes the northern lights are seen as far south as southern United States. Such sightings happen only when the sun is very active. Very active means sunspots are more, and the emissions, eruptions by the sun in terms of solar flares are stronger and bigger. So when you have giant solar flares, then you have a large quantity of these particles from the sun. They are being bombarded in large quantities as well as with too much of energy, and they travel at great speeds, and then they penetrate into the magnetosphere. And if they penetrate much interior, then they can come to influence the things in the lower latitudes than polar region as such. Now we come to the next question. the questions, first part is what is a twister? And then the second part says why are the majority of these twisters are observed in areas around the Gulf of Mexico. Now see, twister is a North American term for a tornado basically. And this tornado is a very intense low pressure system around which there is a very fast rotating column of air. And this has an accompanied funnel shaped cloud, which is generally on the darker side because it picks up a lot of things from the earth surface, the dust and other things, I think. So it is dark in color and it is a funnel shaped cloud, and generally it is seen to be connecting the earth surface with the base of a cumulonimbus cloud. And this tornado is one amongst the most devastating kind of natural phenomena. The reason being that in the internal part of this tornado, the winds are moving at great speeds. Sometimes they cross 500 kilometers per hour. And these speeds are the major reason for the destruction associated with these twisters or the tornadoes. Now, when these tornadoes cross over the surface of the water body, then they are called water spouts. And when we look at their dimensions here, then a tornado path on the ground is generally less than a kilometer in width, but it may be as about 30 kilometers long, and they are not lasting for a long time as such. Rarely they have been seen to go beyond 30 minutes. So these are very intense systems. They do not survive much long, and it's good that they do not survive much because they are a reason for great destruction on their path as such. Even buildings cannot stand their onslaught. Means unless until you have very special designs for these buildings, they would not be able to to handle this onslaught of these strong winds which go beyond 500 kilometers per hour sometime. The system is moving at a slower speed. The system as a whole means if we see their movement across the surface of the earth, the system is moving somewhere between 50 to 80 kilometers per hour, but the winds within the system are very, very strong. And generally, these tornadoes have anti-clockwise circulation of air. Some of them do have clockwise also, but majorly they are found to have anti-clockwise kind of circulation. Now see, the question has given the second part that we have to account for the reason that why they are seen more in the areas of US near to Gulf of Mexico. In fact, before we come to that, US is the country having most of the tornadoes of the world. As much as 75% of all the tornadoes of the world are seen or are observed in United States only. And the second place is with Canada, and US has about, my handout would mention that US has about 1,300 cases on an average per year, whereas Canada is at the second place, but too distant a player at the second place with only around 100 such episodes in a year. And the reason for this high frequency of tornadoes in US and Canada is a mix of geographical and climatological variables. Now coming to that area of Gulf of the area which is under the question here in the second part, they have mentioned that why it is that we have majority of twisters in the Gulf of Mexico. Now here we have a mix of geographical and climatological elements which provide the ideal conditions for this twister to form. See, for a twister, first you need a thunderstorm. Only a few thunderstorms would give us twisters. And we have some ideal conditions for a thunderstorm activity in this area. So this is your Gulf of Mexico. So think of the southeastern US and think of mid-USA, mid-American region. This region has no barrier for the cold air masses to come from Canadian side. Since there is no east-west mountain to act as a barrier, so cold air masses come from the Canadian side, and the warm air masses which are full of moisture are going from the Gulf of Mexico. And then you have here the jet stream in the upper troposphere, which is also playing a role for providing the kind of essential elements which are needed for a twister to form. So we write here. Now see, so there are three things to focus. That one, you have warm moist air from the Gulf of Mexico moving northward. Then there is a cold air coming from the Canadian side. Then there is a role of one warm, and rather it's hot air, which is dry air from the plateau region of Mexico. And when this hot air, this is hot and this is warm here, when this hot air would move here, it would be lying over the warm, moist air of the air which is coming from Gulf of Mexico. This would create a sort of temperature inversion and would not allow this warm air to go further up for some time. And in the meanwhile, this warm air which is staying closer to the earth's surface will pick up a lot of moisture, and that moisture is needed for this tornado to form, and it would have a lot of convective activity also in that same time. And because of that convective activity, it is able to puncture through that temperature inversion layer, and then the cold front which is formed because of the cold air coming from the Canadian region would uplift the warm moist air. So you need, for this twister, for this tornado, you need a lot of convection of warm and moist air that is being available through the kind of things I have mentioned. And then you need some sort of rotation, and that rotation will come from the jet stream's role, because in the upper troposphere the wind is moving in a different way as compared to the surface wind. So that creates a vertical shear in the system. Vertical shear means as I go up in height, there's a change, there's a significant change in the direction, speed of the air circulation. And all these things together means some geographical and some climatological, they make this region as what is called tornado alley of the world or of US. That this is that small region where you have the maximum tornadoes, though they occur in other parts of US also, but they occur the most here. So I write here in very clear words that what are those conditions which are making it, and this is the way you have to give the answer for good score. So I write here, the American Midwest and Southeastern US is a prime location for the tornado formation due to the absence of a barrier for cold air masses from Canada and warm air masses from the Gulf of Mexico. The air mass encounter provides all the necessary ingredients for the tornado formation. One is, there's a lifting by a cold front. You know, cold air can lift the warm air to great heights in a furious way, means there's a vigorous kind of upliftment the cold air can do in a cold front, and warm air is lifted to great heights in a narrow zone. So that is one important feature which is required for this thunderstorm, which will turn later into a twister. The vertical wind shear is provided to the upper level jet, which creates the horizontal rotation and then later turned into vertical rotation by convection. So first you will have the change in the wind speed near the earth's surface, that as we go up by convection, the air is going up, it will have the vertical shear also. And then the inflow of hot dry air from the maximum plateau, which I said earlier, would become a reason for temperature inversion, would suppress or would not allow the warm moist air from the Gulf of Mexico to rise much because of that inversion. You know, inversion is that you have colder conditions beneath the warmer conditions. So since this air is warm and the other is hot, so the hot air would not allow the warmer air, the low temperature air to rise for some time. And then it would have more of the moisture being taken from the water body, as well as it will have more convective energy also. And finally this inversion would be punctured, and then you will have the right kind of rise of the air which is needed for the tornado to emerge. So it means you have the essential ingredients for convection, you have a lot of energy because of the warm moist air being there, and the energy would be released through latent heat, and then you have the rotation, the system to rotate in a strong way. Because what is twister? Twister or tornado is a vertical column of air which is rotating at a great speed around a very intense low pressure. So you have low pressure being formed because of the two contrasting air masses coming together. Then there is a lot of convection, the air being uplifted by the cold front, and then you have the rotation which is needed for the system to go on in a strong way is provided with the help of jet stream in the upper troposphere. All these conditions make it the best area for such kind of tornadoes activities to happen. And for this reason, this has been named as Tornado Alley, and since these systems are very, very destructive and they are so frequent, so there is a role of scientific community here for keeping a watch on this. And since we still do not know exactly the mechanism of these systems, so the best we can do is that we can go for forecasting of these by having a mix of all what is available to us. Number one, we can go for observations here, where that what kind of changes are happening in the ocean, the Gulf of Mexico and the land area as such. What kind of things are coming from the Pacific Ocean and from the Canadian region. Then second is that we have to focus on the use of some technical kind of instruments. For example, we go for Doppler radars here, and then we have prepared numerical weather prediction systems for weather forecasting here. The mix of all these three, in particular the observations, the Doppler radars and numerical weather prediction models, they are used for detection of the factors and conditions which lead to this activity, the tornado, or what you call as popularly a twister. And finally, we write about the scale also, that this twister or tornado is measured on a scale which was earlier the Fujita scale, but over a period of time it has been improved upon and it is now called as enhanced Fujita scale. And this scale has 6 categories, EF0 to EF5. And this is a qualitatively based scale. By this we mean that since you cannot measure the speeds of the system, the internal speeds, they are so strong, so you cannot have the accurate measurements that easily. So we are assessing their speeds by having the focus on the kind of damage the system has caused. So by looking at the damage the system causes, we have gone to predicting or making some kind of idea about or estimation about the wind speeds associated with this, with these kind of tornadoes or these systems. And qualitative is the only way out. Quantitative assessment is perhaps not possible today for the speeds to be high as such. So these are the 4 questions which were there in yesterday's GS paper 1. And I repeat once again that this paper, as papers earlier, almost in every section, not only in geography, indicate one pointer is there for every student who is taking this examination, that core strategy for your examination success is to include newspaper reading. Because your examiners are looking for those things, what the country, what the world has been talking to itself for the last 1.5 years. And even in static areas of physical geography, questions are being guided year after year for prelims as well as mains from the current happenings only.
So one of the questions is, why do large cities, that is question number 5, why do large cities tend to attract more migrants than the smaller towns? Discuss in the light of conditions in developing countries. Okay, now it's a 10-marker question. That means you need somewhere 120-150 words here. Okay. Now, there are 2-3 keywords here. One is large cities attracting, or large cities, then smaller towns, and then we have developing countries. Especially the examiner has asked developed, not the developed ones, but the developing countries. Now, understand this. Like, what are you supposed to write here in 10 marks so that you cover all of the valid points? At the same time, you don't exceed the time as well as the word limit. Because whenever we talk about migration, migration can be due to a number of reasons. Like a migration can be due to the political reasons. We may migrate to protect ourselves from religious persecution. Migration can be related to climate. But whenever we talk about migration in the world, much of the migration that we have noticed in the world since very long, it has largely been related to economic factors. It's basically the desire of a man to improve his economic status that leads to migration largely. So whatever migration that we have in the world, it is largely related to the economic factors. Now, looking at the question, listen, whenever migration takes place, see, migration can be from the rural areas to the rural areas. Migration can be from rural to urban areas. Take it. Migration can be from urban to rural areas as well. Take it. It can be from rural to rural areas, or it can be from urban to urban areas as well. Okay. So let's say I am moving from a village in Rajasthan to Delhi, that is from rural to urban area. After, let's say, I am 60 years old, I have lived my life in Delhi, I may try to move back to my hometown or my village wherein I find a peaceful living. Take it from urban to rural areas. Rural to rural areas, let's say I am a young woman who gets married and I'm going to my husband's place and he's living in a nearby village. So rural to rural area, we will have migration. Migration can be from urban to areas, urban to urban. Let's say I'm migrating from, let's say, Delhi to Mumbai, or from, let's say, Pune to Mumbai, or from, let's say, Mysore to Bangalore. All of these are urban areas. There may be difference in size, there may be difference in location. The question basically says that why do we have migration largely? Why do large cities tend to attract more migrants than smaller towns? Now, can I say the larger cities, they will have a better infrastructure compared to smaller towns? Like whenever we define the cities in India, normally the cities are defined on the basis of the population criteria. That means if I have people more than 5,000 in a particular area, if I have more than 400 people per square kilometer as a density, and more than 75% of males are engaged in non-agriculture, then it can be called as a town. But when we talk about towns, towns can be of different grades, tier 1 to tier 6, then we can have large cities or even metropolitan cities. Whenever migration takes place, we will find that it is the large cities that are going to attract more number of people, especially in developing nations, where in most of the developing nations, you'll find that there is a high level of primacy that will be enjoyed by the large urban centers. Jैसे India में we may not have primacy at the national level, but we have primacy at the regional level. जैसे Mumbai is the most important center for the entire Western India. Chennai is the most important center for entire South India. Or for example, we have Kolkata as the most important center in Eastern India, or Delhi as the most important center in entire North India. So primacy is there where certain cities tend to become larger than the other cities. And the question is basically asking, why do we see these large cities attracting more number of people than smaller towns, especially in developing nations? Okay? Now, what difference would it make if the examiner would have said that discuss in light of conditions in developed nations? Why can we not have this kind of situation in developed nations as frequently as we have in developing nations? They understand this process of development of a city. See, most of the cities that we have in the country, most of these are overgrown villages, wherein over a period of time, they have grown to the size that we have these cities as of now. Now, in a developing country, we have limited resources. If suppose there are 4 cities, let's say A, B, C and D, okay? And government has limited resources to develop infrastructure in these cities. One way is the strategy wherein I am going to distribute my resources uniformly, wherein I will put in some investment in each of these areas. Okay? As a result, what is going to happen is these areas will be at the same level of development. But we may find that if we distribute our resources evenly, then in that case, what may happen is none of these cities will see the kind of infrastructure development that we want. So generally in developing countries where we have limited resources, the government tends to invest more in certain areas that have enjoyed some kind of historical advantage or that enjoy some kind of political advantage. They say Delhi saw a lot of investment largely after the British made Delhi as a capital. Then in some new areas were set in. If with eventually Delhi becoming capital, industries were also attracted towards Delhi. So primacy becomes a feature of developing countries because of this phenomena. And whenever we talk about migration, a good part of migration will be because of the pull factors, wherein it is the pull of the cities which will be attracting people from other areas towards itself. And greater is the size of the city, greater will be the influence of the city, better will be the infrastructure, more will be the employment opportunities, and it will have a greater influence or it will have a greater pull factor. So I, as a person, know that if I migrate to a small town, then the skill that I have may not be rewarded at the same level which it will be rewarded if I go to a large urban area wherein, or a large city wherein there may be a lot of employment opportunities for the people who possess skills that I also have. So it is largely a phenomena in the developing countries because we have limited resources, wherein certain cities that had historical advantage, which have had political advantage, those cities, they attract more of investment. And if investment comes in one area, then the cities tend to grow. And when you look at the growth becomes cumulative in nature. So if an area develops, then industry will come to this area. It may develop infrastructure, it will attract further industries, and then it starts exerting a greater pull. Okay, so this is basically the explanation part. Now, what are you supposed to write here in this question? Okay. Why do large cities tend to attract more migrants than smaller towns? Discuss in light of developing countries. Now, to introduce, you can talk about the development or growth of cities in India. You can say migration has been a very important factor in determining the growth of the city, and a good number of population growth in a city is because of the in-migration. Okay? So migration has been responsible for growth of any city. Then you can say migration can be due to push factors, migration can be due to pull factors. There can be a number of reasons for migration, but it is basically the economic reason which is the most important reason, wherein most of the people migrate to improve their economic status. Because now you can talk about the body part as well. Now you can say that developing countries, they have limited resources, wherein it is not feasible for the developing countries to have a good amount of resources allocated to every area or every city. As a result of which certain areas which have had historical advantage, certain areas that have had some kind of political advantage, they start growing faster than the other areas. And as the growth process is cumulative, then it starts attracting more of investment and it starts growing further. Greater becomes the size of the city, which we call as primacy, which is seen in most of the developing nations. The city starts exerting greater influence around the area. And greater is the influence of the city, more will be the pull factors, and greater will be the attraction towards that city. It may be a case in developed world as well, but developed areas may, we have a case wherein the governments may invest more in some other areas as well. They say there may be disparity in developed world, but disparity may not be of the same nature as we find in the country. That is very much visible. You can now cite examples. Very much visible, like you can talk about the growth of Delhi. Maximum of the growth of Delhi has been because of in-migration, because Delhi has been the largest city in the entire North India, where it has attracted people from the areas of Rajasthan, from the areas of Himachal, Uttarakhand, from the areas of, let's say, UP, Bihar. So if I look at the population of Delhi, Delhi is very much cosmopolitan, wherein we have good number of Purbiyas, the people who come from east. We have a good number of Pahadis, people who have come from Jammu, Himachal, Uttarakhand. And we have good number of people from the other areas as well, along with the migrants that came after the partition of the country. So then you can cite example of Delhi as well. Okay. So if suppose you are going to conclude this answer, then you could talk about how the measures can be taken to prevent the stagnation of smaller towns, how we can have planning done in such a way that the counter magnets can be developed. Okay. So you can again cite the example of NCR plan, wherein one of the objectives is to develop counter magnets, and number of counter magnets are there in order to prevent the problems that we are having in Delhi because of congestion, or in any other metropolitan areas because of continuous in-migration. Okay. So this is how you're going to attempt this question. Okay. The next question is, what is the concept of demographic winter? Is the world moving towards such a situation? Elaborate. Listen now. The key word is demographic winter. The key word is demographic winter. The question is, what is demographic winter, or what is the concept of demographic winter? What is the concept of demographic winter? Now, basically, demographic winter refers to a term wherein the area does not witness increase in population, where the birth rates they fall below the replacement level, and wherein the population starts aging, that puts a lot of strain on the overall economy. This is what we call as demographic winter. देखो, demography related to population, and winter in the Western world is a time wherein you don't find a climate suitable for the growth of trees. This before the very cold winter season, the trees will start shedding the leaves. The entire area gets covered with snow. The grasses become dormant. So this is the time when no growth is taking place. So demographic winter takes the name from the same phenomena, that this is a condition wherein we have low birth rates, wherein the birth rate is below replacement level, and wherein the population starts aging. New people are not born. The people that were born earlier, they become old, and as a result of which overall economy faces a problem. Okay? This is the concept of demographic winter. Now, in order to explain this, suppose I look at the birth rates, death rate. There's something which we call as total fertility rate. Okay? Total fertility rate. That means the total number of children that woman can bear in a reproductive age group. As a total fertility rate of 2.1 is considered as a replacement level rate. That means if a woman in her reproductive lifespan has 2.1 children, then in that case, we would have the population which is replaceable. That means if a husband and a wife, they have 2 children, a son and a daughter, at a natural course of things, what is going to happen is, if the death is due to only old age related complications, husband and wife are going to die first. Once these people are dead, then in that case, these 2 people, male and a female, are replaced by another male and another female. This is replacement level population. If suppose I have a case wherein a husband and a wife, they have no children, or husband and a wife, they have only a son or a daughter, then when these 2 people will die, then 2 will be replaced by only 1. When these 2 will die, then they will be replaced by none. So if we have a couple not having children, or a couple having less than 2 children, then in that case, we may have a population which is below replacement level. Okay? Now what has happened is, like, fertility depends on number of factors. Fertility will have 2 things. One is, it is biology that determines fertility. Second, it is society. Okay, fertility is decided by either of the 2 things or both of these things, biology as well as society. Biology means that there is a certain reproductive age group. There's a certain age group in which you can produce babies. For example, if I am a woman who is aged 45 years or 60 years, then in that case, it would be impossible almost for me to produce a new baby. That means my body will not release that many eggs which it should release for fertilization. So one is biology. Second is society. That means children are a resource which will demand a lot of time. Children will demand a lot of other resources as well. So children, they are going to demand time. Children, they are going to demand resources. So you are going to produce children on the basis of one, social norms. Suppose I in India at this point of time have 8 children. Then in that case, I would be laughed at. That is a person who has 8 kids. So I need to look into society norms as well. Second, it also depends if suppose I am working and my wife is also working. And what if we have a system of nuclear family where joint family system is broken down? What if I have a nuclear family? What if I have 4 kids? Will I be able to bring those kids with a good value, with good, let's say, education? I may not have the monetary resources. I may not be able to give time. My wife may not be able to give time. As a result, what is going to happen is the rearing of children will not be qualitative. Okay, so what has happened in the world today is that because living standards are rising, because cost of living is very high, because joint family system has broken down, because we have seen continuous urbanization, and because today there are better opportunities available for females to work, we have noticed certain changes. Changes one, that couples are choosing to have less number of children because they don't have monetary resources. Second, they don't have the capacity to bear so many children in absence of a joint family system. Third, the age of marriage is delayed. If age of marriage is delayed beyond a certain point, then in that case, you are left with a limited time span in which you can reproduce. Delaying marriage can also be one of the reasons behind having less number of children. Okay? So, when I look at the situation of demographic winter, this is a situation that is found in many areas of the world. Just for example, US. US is a country where median age of population is 48 years. If I look at a country like USA, time was there after the Second World War, 1950s mein. 1950s mein TFR in USA was more than 3.5. That means in USA, a woman was expected to have more than 3.5 children, or you can say 10 women were expected to have 36, 37 children during 1950s. This was a time of baby boomers. This was a time wherein after Second World War, when the conditions improved, as a result, new children were born in US. But today, if I look at USA as well, this is a country wherein the TFR is now less than 1.65. That means we have a TFR which is much less today. 10 women are now having only 16 children collectively. Same is the case in Canada, same is the case in European countries. If I look at Italy, if I look at Germany, these are also the countries wherein TFR is below replacement level. New children are not being born at that pace. Japan is a country of old people. Or just look at a neighbor, China. China mein, today we have a condition where people who were born before 1979, before China came up with one-child policy, those people are now old, and now new children are not being born. So Chinese government is now very aggressively promoting the couples to have more number of children. The reason is China needs people to work in its factories. Okay, so what we are witnessing is Japan, China, Scandinavian countries, Germany, Italy, US, Canada, all of these are the countries wherein we have TFR which is below replacement level. Achha, if I look at India, National Family Health Survey 5 says that TFR in India is 2.0. This is the TFR. Below 2.1, that is below replacement level. If I look at the southern states of India, Andhra Pradesh, Tamil Nadu, Karnataka, these are the areas wherein TFR is below 2. National Family Health Survey says Tamil Nadu mein TFR is 1.8. Because these are the areas wherein we have better employment opportunities available for women. These are the areas where when both the couples are working, both the partners are working, then in that case, you don't have time and resources for rearing many children. So we are also going to witness this kind of demographic winter if the conditions persist. Yahan par the advantage is that there are certain states, जैसे Bihar, UP, wherein the TFR is very high, birth rates are still very high. That is why India still is a youthful country. But we are also moving towards that. Achha. So the question is, so this is basically the explanation part. Now what are you supposed to write here? What is the concept of demographic winter? So you explain the concept, condition wherein the birth rates are low, wherein the population starts aging, and wherein we have a good strain on the economy because of this kind of demographic structure. This is demographic winter. Okay? Where birth rates are below replacement level, wherein new people are not born with that pace, and the people who are born become old, and the population, it puts the dependency ratio increases, and because of more of old people. Okay? Is the world moving towards such a situation? देखो, अभी right now for me it would be easy to write this wherein I can get a number of examples, number of statistics. मैं statistics ले आऊँ that South Korea में the total fertility rate is 0.78. I have statistics that in the areas of USA it is 1.64. In the areas of Germany it is 1.5. Now I have the statistics because I know this question has been asked. But most of the students, when they are writing, they would not have ready statistics with them. They may have statistics related to India. So even if you don't have statistics, still you can write a good answer. You say, yahan par you can talk about how a country like USA has a very high, has a aging population where the median age of population is 48 years. The people who were born at one point of time during the time of 1950s, now TFR has drastically fallen. New children are not being born because of the factors which may be related to the societal norms, which may be related to the economic norms, or which may be related to the oral biology. Okay? Then you can talk about European countries as well. Okay? European countries may you will find that this is a situation as well, because again those are developed countries. Okay? Again वहाँ पर भी Second World War के बाद was a good rate of population growth, but which has declined now. You can talk about Japan being a country of old people. You can talk about China, how in China we have seen successive changes in the policies. 1979 के बाद से when we had one child policy, 2016 में they diluted the policy and said you can have 2 children. Then 2021 में they further diluted and said you can have more than 2 children, because China is also staring at this demographic winter. Then you can talk about India, how India mein conditions are there for demographic winter in the southern part. It's just that certain areas of UP, Bihar, they have a high population or high TFR. That is why we are less likely to face this problem anytime soon. Then you can talk about certain countries of Africa. There's certain countries of Africa, let's say Nigeria. These are the countries, or these are countries wherein the birth rates are very high. Still, we have large number of young people in those areas, or very large number of people in the young age group, which are below 15, not even working age population. The base of pyramid there is very broad. So you can talk about African countries, you can talk about Pakistan, let's say, again, better fertility is there in Pakistan. So you can say, yes, it is a phenomena in most of the developed countries. It is a phenomena where world is moving towards demographic winter in the developed world. In areas of Europe, in areas of US, Canada, areas of developed world in Asia like Japan or South Korea. Or you can also then talk about how we may move towards this situation in a country like India as well, but situation in the areas of Africa may be entirely different. Okay? This way, even without statistics, you can write what you want to write here. Okay? Then in that case, towards conclusion, then you can talk about how certain programs have been started by certain governments, how the demographic dividend can be reaped by certain countries like India, how this demographic winter can be arrested, wherein how the countries can promote the growth. Okay, so this way you can conclude the answer. Do not conclude the answer writing the problems about the demographic winter. What will be the problems? We know that there will be a good strain on the economy. There will be problem related to geriatrics, wherein population of old people will be very high. Government will have to spend more amount on infrastructure. So what you can do is you can say that, okay, we may have this kind of a problem in India as well, but government needs to be ready for that. We need to scale up our medical infrastructure. We need to focus on providing these services to those old people. And we may also have campaigns wherein awareness can be created about this kind of a problem. Okay? So this way you can conclude. Do not conclude the answer on a negative note. Okay. Then there's a question. The groundwater potential of Gangetic Valley is on a serious decline. How it may affect the food security of India? Okay, it is 250 words. One, groundwater potential is a keyword, Gangetic Valley, and then food security. Because suppose I look at this term, groundwater potential. Basically, potential means what is the total amount of water that this area can hold. Area if has a groundwater, it may be dependent on certain things. Pehla, groundwater availability in any area depends on the rainfall in that particular region. Okay? Greater is the amount of rainfall, more will be the chance that there will be more amount of groundwater. Second, it will also be dependent on the water bodies, let's say rivers, lakes, ponds, or even artificial structures like dams. If I have some water bodies, the water is going to percolate and it is going to recharge the groundwater table. Then it will depend on the movement of groundwater. because groundwater is also not static. It keeps on moving at the subsurface level. So at the place where we are looking at, it may be the case a lot of groundwater is coming from the subsurface level. Then it will also depend upon the rock structure. Okay, whether the rock can hold some amount of water or not, whether it is porous, permeable or not. Okay, so potential of groundwater in any area will depend on these factors. Okay, so what is the amount of water that a area can hold will depend on rock structure. It will depend on rainfall, which is going to help in recharging that water, and which will also depend on these factors. So potential, it means total amount of groundwater that an area can hold, and it depends on these factors. Okay. Achha. Then it says discuss the potential. The question says groundwater potential of Gangetic Valley is on a serious decline. Now, examiner is telling you that it is a fact that groundwater potential of Gangetic Valley is on a decline. Okay. Achha, it is true. And even if you don't agree to that, you cannot say no, but you will have to agree to the statement because it is mentioned by the examiner here that the potential is declining. Achha, now the question is, when you introduce it, okay, you can talk about Gangetic Valley, how it is very important physiographic structure of the country. Okay. You can talk about how the Gangetic Valley provides the food grains which is used for feeding a large number of people all across the country. Okay. Or you can talk about how groundwater has been an essential component of way of life in the country, especially in the Indian Gangetic Valley. Okay. This way you can introduce the question. Then groundwater potential of Gangetic Valley is on serious decline. Okay. Now, why is the groundwater declining? One of the problems is that when you talk about climate change, with the climate change, what has happened is the chances of extreme rainfall events have increased. What we have noticed is that there are more number of dry spells today and more number of times wherein we will have very intense rainfall. Rainfall is not uniformly spread. We will have few hours of rainfall, but that will be heavy downpour. If heavy rainfall takes place, in that case, it will not help in recharging of the table, because greater is the amount of water, more will be the energy, more will be the surface runoff, and less will be the recharge. So one is climate change can be a reason, or is a very important reason here. Achha. Second, can I say we have the deforestation, or let's say you can say land use change. Okay. You can have land use change. Achha. Land use change, say what has happened is, with the land use change, what we have noticed is with urbanization, concrete structures have been created. That means we don't see the water penetrating down. We have cut down forest in a number of areas, and the roots of the tree, they hold the soil, they stop the flow of water, and as a result, when the water speed reduces, as a result of which the water percolates down. Okay. Then can I say that with urbanization, what has also happened is that we have completely changed the land use system, wherein we have destabilized a number of areas in terms of the slopes. Slope stabilization or destabilization means faster movement of water and less of the percolation. This is one. This is related to one. Second, and a more important factor is, what if the water table is getting recharged, but you are taking out more amount of water than the rate of recharge? That means over-exploitation of the water. Today, when you look at the agriculture in India, Central Groundwater Board says in 2022 report that 87% of the groundwater is used just for agriculture. When the cropping patterns have seen a change, where even in the western part of Gangetic Valley, where you had a good amount of groundwater, you started cultivating sugarcane and rice, then as a result of which you are using groundwater for this. And Gangetic Valley, right from UP up till the areas of Bihar and Bengal, is the area wherein we have good amount of agriculture practiced with the help of groundwater. So overexploitation is also the reason. Okay. So question is not about what are the reasons for decline, but the question is, it is on a serious decline. So you can say that groundwater potential of Gangetic Valley is on a serious decline, and potential in any area depends on these factors, and there are a number of reasons why it is declining. Okay. Achha, then you can talk about how this second part of the question, which says how may it affect the food security of India? Because we are a country which is the most populous country of the world. Okay? We are a country wherein we still have a good growth rate of population. In the next 20-25 years, we'll add another 20 crore people, and as per UN population projection, we are going to stabilize somewhere at 160-170 crore. That means from 140, we will add 30 crore more people by 2050, 2060. So we need more amount of food in the country. And to produce food, we need more amount of water. We have rainfall, but monsoon is highly unpredictable. The predictability of the monsoon is declining with the climate change as well. Even it is becoming more difficult to predict monsoon with 100% accuracy. So we need to provide the groundwater, or we need to provide water for irrigation. And groundwater is the most important source of irrigation, and almost 64% of the total area which is irrigating the country's land, it is irrigating the country using groundwater. So if the potential to hold the water reduces, if you don't have enough amount of water, then how will you cultivate the crops? And if you're not able to increase the agriculture production productivity, how are you going to feed the people who are going to be born in the country in the next few years? So if we are stabilizing at 160 crore as well, still we will have 20 crore more mouths to feed. And this is the most fertile land of the country, which has not only very high fertility, but also has some good amount of water as well for cultivation of crops. If yahan par potential declines, and in that case, it will be a serious concern for overall food security in the country. Okay? So again, if suppose I look at the question, the groundwater potential of Gangetic Valley is on a serious decline. So yes, you can say, if suppose I have to introduce this, I can say Gangetic Valley is one of the very important areas for agriculture in the country, where it has been blessed with a number of rivers, a fertile alluvial soil, and also a good number of people who are practicing agriculture. Okay? This is the way I can start the question. Okay? Then I can say groundwater potential of any area depends on the factors. And it has been noted that due to certain changes that we have seen in the land use pattern, certain changes that we have seen in the cultivation or cropping patterns, and along with climate change, the groundwater potential of Gangetic Valley is on a serious decline. Okay, then you can very briefly explain the factors that are leading to decline. Okay, very briefly, because this is not the major part of the question. Okay, then you come to the second part, how it may affect the food security. Now give us a heading, effect on food security, and then you write that Gangetic Valley is one of the very fertile areas producing a lot of food, and the food grains produced in these areas are used for feeding large number of people all across the country. Agriculture in the country to a large extent is dependent on the groundwater for irrigation purposes, and in the absence of irrigation, with monsoon becoming more unpredictable with the climate change, it will cause a serious problem for the food security of the nation. If the water is not available, which is otherwise used for cultivation, or the water is contaminated, then in that case, it may present a serious threat to food security in the country, because these are fertile tracts. Now you can mention that, for example, West Bengal has been a major producer of rice in the country. UP has been the largest producer of wheat in the country. We have West Bengal, UP, which are producing a good amount of fruits and vegetables. Like we have these two as the largest and second largest horticulture producers of the country in terms of potato production. Okay? So yahan par you can cite certain statistics, and how you can say, then you can talk about how in the future more food grains will be required because population is going to increase, and if the areas lose water, then in that case we may face serious concerns. Okay? Now conclusion part, conclusion where you will write about certain steps what can be taken. So you can say we need to change the cropping pattern, we need to have more of planned development, and land use change should be taken up with the consideration of the groundwater in mind. Then you can also talk about how we need to go for water harvesting of rainwater and so on. Okay, this is how you're going to attempt the question.